So please give a giant round of applause for Elad.
Hey. Oh, wait. I have to unmute this one. Hey. I remember the first time I had to configure a Redis cluster in AWS. It was a humbling experience. It was my first time building this big system, and we were about a week before the release of this new change to the Amazon search cluster. I used to work at Amazon. And I was naive. I was like, there's this junior engineer in my team, and we had some latency issues, so we said, okay, let's add a Redis cluster. And I asked them to go and check what that means. And so he comes back a day later, and he's like, I think we need to put our system inside the VPC. And this is like a week before we released. And I'm like, okay, let's put the system inside the VPC. And then he comes back 2 days later, and we're like already 3 days before the release and kind of becoming a bit stressed out. And he starts asking me about CIDR blocks and IP and NAT gateways and routing tables. And to me, this was great. I love this shit. But then I realized that something's broken, right? We were trying to deliver value to customers. We were trying to create a system that helped solve a problem for customers. And instead, we spent the next 3 days figuring out how to set up our VPC and configure our CIDR blocks and set up the NAT gateways and the VPC endpoints. And this was actually when the CDK was born. This project was the project that where we created this internal system, the internal tool that helped us generate CloudFormation templates. Because for me as a developer, having this experience made me realize that we're not working at the right level of abstraction. And as a developer, when you have a hammer, everything is a nail, I guess. And so as a developer, I need programming languages in order to manage complexity. For me, that's the right tool. And so, hi, I'm Elad. Thanks for having me. This is a really, really, really cool group. I feel at home, to be honest. It's my first time here, but I feel I'm with my people in a sense. So really thank you for inviting me and having me here. It was awesome to hear all the talks yesterday and today, and I feel like we're all kind of talking about the same things, with different perspectives and different mental models. And so I wanted to talk about my mental model. Adam said art is how you see the world, and so I think this is definitely how I see the world. So basically, I think that the cloud is kind of like a jungle today. It's amazing. It's this organic system. It evolves and it's rich, and you can do everything. You can build everything you want. You can lean on services to solve some of the hardest problems. But it's a pretty hostile and intimidating place. We talk to people a lot, new developers trying to use the cloud and companies trying to migrate to the cloud. And I'm sure that all of you kind of see this experience of people trying to figure their way out. I mean, they either have to be heroes to fight the AWS monsters, the IAM roles, the VPCs, the subnet masks, understand everything about 180 services. I like to call them, they have to understand, they know the incantations of how to connect a queue to a Lambda function. That's there's 3 resources involved dancing around. Or if they're using Kubernetes, I kind of feel like they're like this. They're just shoving their developers into a container, and it's okay, you just don't care about the cloud. We figure out the cluster and all of the things around it, but developers can't really use the cloud this way because they're locked into the container. Alternatively, you climb up to one of the vertically integrated cliffs that are Vercel or Render or Roku or one of these amazing platforms, and you're sitting back and relaxing, and you have this beautiful view, And every time you submit, you push code to your GitHub repo, you get a glass of champagne with a preview environment, and you don't have a care in the world. You really can deliver until you realize that server-side components are not necessarily the backend you need for your mobile app, right? Because you're building a front-end thing and like something's not really adding up, and you need to, do some big data analytics or something. And so you basically jump off the cliff and back to the ground and trying to find your way to the other side of the jungle, figuring out how to do, I don't know, ETL jobs, which is something that a lot of people need to do, as well as build front-end applications. And I think this is kind of like the reality that we have today. And that's okay, like we've built this amazing thing together. We're still building it. I think all of us are trying to improve it and make it better and better and better. But this is not this is not the end. This is not the end game. I think we're going to use the cloud in the next 10, 20 years. That's easy. That's an easy bet. But I don't think that we're going to use the cloud the same way we're doing it today. Like, it's just too fucking hard. And I just talked to a friend of mine who's built a company in the past 10 years, and he's getting back to programming. And he complained that when he started his company, his service was basically a server under his desk and with a public IP address, and that's all he needed. And now he can't even set up like a simple Node.js process on the cloud. Like something's not right. And I'm a jungle explorer. Don't get me wrong. I think like all of us are jungle explorers. We like the jungle. We like to open up the hood and understand how things work. But if we're not building the right platforms for the developers to be able to actually deliver, then we are not done. We need to work harder. And so I guess the question is like, can we turn the jungle into a park? That's the big question, right? Like, are we able to take this hostile place that's not really designed for humans and turn it into something that's as rich and as useful, and that you can do many things in, like you can go, but it's designed for humans, right? Like you can go to the park and play ball with friends, or read a book, or ride a bicycle, or catch fish in the pond, but you're not in a dangerous situation. Your life are not threatened. And so I think the question that we're all asking ourselves, one way or the other, is like, can we turn this computing jungle into a park? And I recently came to the realization that I'm old. I actually turned 44 last week. And I've written code in the 90s, and I think a lot of you also. Which is really, that's maybe why I feel like I'm with my people, because sometimes when I talk to developers today, it's like their first programming language was HTML, or actually no, it was Next.js. That was their first programming language. But I used to play with computers when I was young, and I used to go to it was a jungle. It was a jungle back then. Like, I used to go to the shop every couple of weeks and get another RAM card and push it into my PC. And I asked for a Sound Blaster for my 15th birthday. That was like so cool. And I loved it. I loved every minute of it. I think I reformatted my hard drive like every week, basically. I had like a little checklist, and I set up my autoexec.bat and like my menu and everything. But I grew up, and the industry grew up, and computing grew up and evolved. And today we actually have a pretty nice park in the PC world, right? Like, I can actually write a file without even knowing which file system I'm using, which is mind-blowing, right? Like, if I can write a file without even knowing which operating system I'm using, which is also mind-blowing. And so I think like being old has some benefits, because you suddenly see what happened, and you're like, okay, we can fix this. We can actually get something like this jungle to become a park. And so how did we do this? Basically, we created abstractions. And one way to think about it is kind of like this line between between application and platform. When I started programming, my favorite thing was to build TSR programs, terminate state resident programs. who knows what TSR programs are? Okay, that's a nice number. So yeah, basically what you did is you wrote some code, and your program, when it started, it basically updated an interrupt vector of the CPU for the keyboard or for the timer. And when it exited, it told the CPU to keep the program resident. So basically, the execution stayed on, the executable code stayed in memory, and when an interrupt happened, when you pressed the keyboard or the timer elapsed, it called your code. So you could build these really cool background applications. My favorite one was Sidekick. Who knows what Sidekick is? That's going to be nice. And so back then, my platform was literally the CPU. Like, I didn't even have an operating system involved in this experience as a developer. Today, I can't even do that because CPUs have protection rings, and the kernel, I can only do this from the kernel side. But I work at a very high level of abstraction. And so by creating a little calculator, I don't need to override interrupt vectors in order to create a calculator that runs in the background. And so we've managed to create these higher level abstractions using two fundamental layers. One of them is programming languages, and the other is standard libraries, and obviously the operating systems that that evolved over time below them. And I've been talking about this with a lot of people, and I think, like, especially in the config management crowd and DevOps crowd, one of the things I get a lot is, like, abstractions are always leaky. They're not going to work. People don't understand what's going on behind the scenes. They're going to make all the mistakes. And I agree. I think, I love this quote by Joel Spolsky. This is actually when, if I understand correctly, this is when the term leaky abstractions was coined, which I think is this beautiful term. But I think it's really important to mention that whether abstractions are leaky at some point, it doesn't mean they're not valuable. It doesn't mean they're not powerful. And a simple example is, like, when you're clicking a mouse, a button with your mouse on your screen, you're basically using like 10 levels of abstraction. There's like 10 layers of things that are happening as you click on your mouse. And in your head, this abstraction is, like, in most cases, very solid. Your head just thinks that, hey, it's my finger actually clicking on this mouse. I don't even think about this cursor. I don't think about the rendering of the button. Like, there's a lot of things happening. Sometimes this abstraction breaks if my CPU is clogged, or I don't have enough memory, or there's a bug, and the button is not getting clicked, or my mouse is jittering, or something like that. But for most cases, the abstraction is very valuable and very powerful. And without it, people wouldn't be able to use this application, right? And I think that's another really important thing about abstractions, is that abstractions democratize technology. And I think it's something that we really need to kind of think about. I think a really good example recently is ChatGPT, right? Like, I think every talk here had talked about ChatGPT. I think ChatGPT is a really interesting one because you see how it's leaky, right? Like, look at this leaky abstractions over there. But is it useful? Is it powerful? Of course it is, right? Like, I made this deck with it. I even made the point with the leaky abstraction. But another really interesting thing about ChatGPT is, like, it's really an amazing example of, like, democratization of technology, right? This technology was only usable by machine learning experts became usable by my mother, right? Like, basically overnight. And so I think we really have to respect abstractions. I feel like there's a message here about respecting the power of abstractions and respecting the impact of abstractions on our industry and on access to technology, right? Like, being able to give more people access to a technology or a platform like the cloud, giving more inexperienced engineers access to this technology is a good thing. There's always going to be need for experts. There's always going to be need for people who will be able to debug problems in production and configure the JVMs and configure the routing tables. but being able to use this technology, but giving more developers the ability to leverage this technology and lean on the cloud and leverage the capabilities of the cloud will improve our entire industry. So as I said, I think all of us are trying to do this one way or the other. So let's look at where we are in the cloud. I think we're not in a great place. I'm just as an example, taking two popular programming models. One is Kubernetes and the other is serverless. And I think neither really gives us what we want. With Kubernetes, developers are containerized, and so they can't really use a lot of the cloud, and everything is platform, including my API gateway. You know, like the definition of my API is that's not platform, that's like the application, right? The queues that connect pieces of my system, they're functional, they serve a function, they serve a business need, but developers can't really leverage them directly, right? Like they have to go to YAML manifests and update Helm charts and do things that are not natural to them. And if you look at serverless, it's almost the other way around. We give developers too many responsibilities, and they have to become DevOps experts in order to be able to actually do something. And they have to configure Redis clusters and VPCs in order to be able to like deliver serverless applications. And I think it's really important to respect the fact that there are two problem domains. I think that was one of my blind spots coming out of AWS, is that everybody at AWS is a DevOps engineer. Like all developers are effectively DevOps engineers, which makes total sense because the problem domain, the AWS is building infrastructure services. And so it makes sense that all developers at AWS would understand how network works and how deep infrastructure technologies work. But if you go to Airbnb, it doesn't make sense that the developer would understand how networking works, right? Like that's not really required because their problem domain is the problem domain of renting spaces, not the problem domain of the infrastructure. And so I think it's really important to respect the fact that we have two problem domains when we're delivering to the cloud. We have the problem domain of the platform. I think most of the people sitting here this is their passion. This is the problem domain that they're enjoying problem solving in. And we have the problem domain of the business, which is where developers need to problem solve. And so putting this line in the right place is where Winglang comes in. And so basically that's what we're trying to do with Winglang. It's a programming language and a standard library. It's basically filling out this line that connects application and platform in a better model. We first released it in December 2000, like basically a year ago. It's still not 1.0, so it's early days and a lot of things to do still. It's built by an amazing team that I wanted to give a huge shout out to, and an amazing community that's starting to evolve around the project, and really, really enjoying seeing this activity and the amount of love that goes into this tool. It's a strongly typed, object-oriented, garbage-collected language, so it's like a standard kind of modern object-oriented language. You'll see the syntax is going to be really familiar. You're going to understand everything I write without me having to go through like, a tutorial of the language. Like it's going to be very easy to understand. We have a batteries included toolchain approach, which means that the toolchain is shipped with everything a developer would need. It includes a testing framework. It includes IDE integration, a compiler. So it's kind of like a one-stop shop. You don't have to like set up like 3,000 tools in order to get like a simple application running. It interoperates with NPM and JavaScript. So it compiles to JavaScript. The runtime is JavaScript. We chose JavaScript because it's the biggest ecosystem on the planet, and it's also very popular in cloud development. The license is MIT. Adam was asking which parts are open source and which parts are not open source. And so the language and the SDK are MIT licensed and open source. And the Wing console, which is this development tool that you'll see, that has a commercial license. It's still source available, but it's commercial. Okay. The next question people get, the first question people get people ask us is, do we really need a new programming language? Obviously, I'm assuming that's what's in everybody's head right now. And the answer is has always been no, like to this question. And I think it's really interesting. I think like in every case where we had new programming languages introduced, and in every case we had new programming primitives introduced, there was always a way to express those ideas without those primitives. Like I wrote a lot of object-oriented code in C, and I loved it. I loved setting up the vtables and the calls and the structs with the this pointer in the first argument, and it was great. As I said, I'm a jungle explorer, so for me, doing that is always fun. My favorite thing was like to write COM interfaces. That was too hardcore. But then we invented object-oriented programming. We added primitive to languages so the developers don't have to think about how vtables are set up. And it's true for many different examples, right? Like async and wait was introduced in C#, and before that we could write asynchronous code. It was just a lot of boilerplate and glue logic and mental capacity and cognitive load that was required. And Go introduced Go routines, and Java introduced threading primitives, and Erlang introduced the concept of multiple processes. And so for Wing, this is the concept that we have in Wing is called pre-flight, in-flight. And it's, in a sense, the way I see it sometimes, it's kind of like an evolution of the asynchronous programming design. One way to think about it is like when I'm writing code that runs on a CPU, right? Like traditional, I call them traditional programming languages. Then I write my code, it compiles, I get a set of instructions, and the CPU executes those instructions. And so in a sense, it's basically describing something on the time dimension, right? Like it's basically a description over time. But when I'm building cloud applications, I also have a space dimension. I also have like an architectural model. And my code is actually distributed, right? Like it's executed over time across different compute primitives, right, on the cloud, like on containers and Lambda functions or VMs. And so in a sense, when you're creating cloud systems, you have both the space dimension and the time dimension. And what Wing is designed to do is it's designed to combine these into a single programming model. So that's kind of like sometimes how I think about it. The other way to think about it is basically pre-flight is infrastructure, in-flight is application code. Or sometimes you even can think about it as compile time and runtime, because pre-flight will be executed in compile time. And so luckily we managed to get to the point where I'm starting to write code, so that becomes much more fun. OK, so I'll start with pre-flight. And the reason I start with pre-flight is because pre-flight is the default programming space for Wing. It's a unique approach because in most cases, the default programming space is the runtime code, not the thing that runs when you're compiling your program. Like if I actually write some code here and I compile. Oh, I'm not sharing. OK, let me do that. Thanks for not letting me build the entire thing with it. Actually happened.
We got you.
OK. Size is OK?
Want me to dim the lights so you can see better?
Yeah.
OK, so basically if I do this, oh, it has to be this, right? Oh, it's still. Light theme is better? OK. Let's not tell anyone. OK, so I'm writing my code. And interestingly enough, I compile my code, and this code gets executed. And so that's what I basically said earlier. Pre-flight is part of the compilation step. It's part of the compiler. And it'll make sense in a second. But the way to think about pre-flight and Wing is basically a desired state configuration language, which are all words that everybody here likes, I think, maybe besides the language part. But for all intents and purposes, you can use Wing, only use Wing pre-flight to produce desired state models. And in that sense, it's very much like the CDK. I built the CDK, and for me, Wing is kind of like the next evolutionary step. And so the foundation is being able to describe the infrastructure, describe the desired state of my system using a rich programming model. And so I'll give you an example by basically bring is kind of like the import for Wing. This is the CDK for Terraform AWS provider module. And it basically contains all of AWS's resources. And so I can create an instance. I can say, OK, let's create an instance. And I have like all the documentation here comes from the CDKTF code. I don't know AMIs by heart, sorry. I'm sure some of you do. And so let's do something like this. And when I compile this now, sorry, I need to compile this and I need to specify the target. And so when you compile Wing, you specify the target platform provider. And I think Adam mentioned it earlier, mentioned it yesterday when he talked a little bit about Wing. Wing has a modular backend, like many other compilers, right? Like you could actually switch the different backends. And so same way as a C compiler can compile both ARM and x86, or compile both Linux output or a Mac output, then Wing has the ability you can basically create a backend to the compiler that determines things about the compilation target. And so the built-in platforms are TF AWS, TF Azure, TF GCP, current ones, right? AWS CDK, that's a CloudFormation output actually. But as I said, it's an extensible model and anybody can build those backends. I'm going to use a Terraform one. And in this case, it actually doesn't really matter that it's an AWS because I could use anything in the Terraform ecosystem. We were just talking about adding like a Terraform, pure Terraform output. And I'm going to go to the target. And not very surprising, I have like an instance here. Now, one thing to notice is that this name was automatically generated for me. And it's based on the type of the object that I'm creating. Now, that's obviously not good enough for desired state because, for example, if I create two instances, then the compiler starts yelling at me because it cannot create another instance with the same name. And so Wing has the ability to basically specify the name, right? So I can basically say my instance and your instance. And now when I compile this, you can see my instance and your instance. Now, this gets interesting when you're composing things together. And I think the most important thing about any programming language or any programming tool is composability. I think like all of us have created frameworks and being able to actually take building blocks and compose them into higher level abstractions. And so in Wing, we use this, we basically use classes to do this. So let's create a class that represents a fleet. And what I'm going to do here is I'm going to do, let's put fleet size. And then I'm going to do host I. So now I created this new thing called a fleet. It's no longer instance. And I can instantiate it. And I can specify, let's create a control plane and data plane. Sorry. And now when I compile this, you'll see that basically Wing used the full path of the resource inside my object to produce a unique identifier for the resource. And so this is a really important piece of Wing that enables it to be a desired state configuration language. This is This is basically something that's coming from the CDK, like this idea of being able to actually use compose objects together into hierarchies and still generate these deterministic and stable identifiers is key to to anything in this space. And Wing has this built-in support for it. Cool. So this is just giving you an example of like the lowest level experience in Wing. Yeah, question?
So there are like now 200 of those entries in the JSON file?
202.
202.
Yes. Yes. Oh, I haven't shown it. Yeah, this is like, it's a big Terraform. And I can do a lot of cool things here. I can also do things like, let's say I create a security group, whatever. I'm not going to give it any properties. And so now I'm going to do SGI, and I can reference it. So I can say security groups. And this is enabled by CDK for Terraform. Basically, because these objects are part of the CDK for Terraform framework, then they have this really, there's a lot of really cool support around like referencing things and synthesizing Terraform output. By the way, there's also support for HCL output that's coming up. Like we heard feedback about that. Okay, so you saw the low-level experience of using Wing. There are a bunch of examples. Maybe I'll show just one more example here. This is an example using the CDK for Kubernetes. Again, it's a CNCF project actually that we donated to CNCF when the first CNCF project donated by AWS to CNCF. I'm very proud of the political maneuvers that needed to happen in order for that to work. So in this example, you're seeing the high-level experience that CDK for Kubernetes offers. It's called CDKs Plus. I don't know if you guys are familiar with the CDKs. But it gives you this really nice high-level API for producing Kubernetes manifests. And so if I compile this, and here I'm going to use a custom platform for CDKs. If I compile this, and I look at the output, I basically get a Kubernetes manifest that I can apply to my cluster. And as you can see, it also uses these ideas of like concatenating, creating like these unique identifiers to same ideas. And so this is basically Wing as a CDK or as a desired state language. But now that we have these building blocks, we can actually create higher level abstractions. And as I said, the problems we're trying to solve are problems for developers. They don't want to create Redis clusters and VPCs, right? Like they want to describe the intention of their application. And so Wing is shipped with a standard library, which is very similar to any programming language that's shipped with a standard library. When I'm using Node.js or Java, I have a standard library. And part of the purpose of the standard library is to abstract the operating system, to abstract the platform. When I'm writing a file in Node, I do fs write file. I don't care which operating system or file system I'm using. And so with the same mental model, we're designing the Wing standard library to be a common library for cloud development. And obviously, it's the lowest common denominator, right? Like it's designed around the idea that all cloud providers or all cloud environments have a bunch of building blocks that are going to be useful. And that doesn't mean the developers or cannot use resources that are not defined inside the standard library, like I showed you earlier. But being able to actually work at a higher level of abstraction gives some really, really cool benefits. One of them is being able to implement those resources across different providers. And so, for example, if I create a bucket and I compile this to TF-AWS, sorry. Then let's close this. Then obviously, I'll have an S3 bucket. But if I compile it to Azure, I need to specify the location, whatever. And then now I have an Azure output, and I see a storage container. And these resources have some API. It's not a very rich API because they're designed to give developers, they're designed to give application developers the right interface to interact with the system. So for example, I can specify the bucket is public. And when I look at the Terraform output, then now I have, compile the Azure one. I have the magic incantation for making buckets public, which is, I guess, what we're asking people to do right now. So this is the Wing standard library, and it's getting started. I think like eventually when we reach 1.0, we'll have about 20, 25 resources there. We're working on resources around streaming and other cool things. But there are already pretty interesting things here. For example, the website resource will deploy to a CDN by default. So you just create a website, you specify the path to your application, so you can say public, and you compile this, and this becomes like a CloudFront distribution with a bucket and more magic incantations on how to do this thing. And so this is one piece of the system that we're working on. We're actually making a lot of effort to test all of those contracts across all the providers. And so that's one of the heavy lifting that we're doing. 10 minutes, oh my God, nuts. We're doing a lot of heavy lifting to make sure that these APIs actually work across all the providers. And so it's kind of like the testing philosophy where you don't have to worry about something that someone else was worried about. Now let's talk about in-flights, okay? So one of the types of, in the Wing standard library, there's a bunch of resources that are compute resources, like functions and services. And they accept an input of like an in-flight closure. And so an in-flight closure is basically, looks like a closure in traditional programming languages, only it has this in-flight modifier in it. And it tells the compiler that this code is going to run later in the cloud. Now, before I show you this, I wanted to show you another thing, is the Wing simulator, right? As we said, there's a bunch of targets here, and one of the targets is sim. And the sim target is basically a local simulator. And so we can take those APIs that we created in the cloud library and implement it using a local implementation. And so for instance, my little bucket here is a bunch of files in my file system, right? Because from a simulation perspective, from a functional perspective, I don't need the bucket to be highly available or highly scalable, and like all those capabilities are needed for production. I don't need them for development. And so now let's, sorry. Oh yeah, that was a blue screen of death. I'm not even noticing that anymore, but it's how we show problems. Okay, so now I'm going to add my function back, and you see, give me a second, something here is fishy. Unexpected JSON, what the fuck? I'm going to, okay. Now I have a bucket and a function, and I can invoke my function, and I can see my log, which is great. And if I compile this to AWS, it'll become a Lambda function and a bucket and all that stuff. But so this is in-flight. But the interesting thing starts to happen when we're connecting pre-flight and in-flight, right? Like that's where the magic needs to go. And the first thing I want to show you is Camp. And so basically, I can do something very, very, very special, which is basically lift. We call this lifting, right? Like we're lifting this string from pre-flight to in-flight. And the reason I'm so excited about it is because it's not that easy to do. It looks super easy here, which is great. That's what we're trying to achieve. And you can see that it works. But it's actually not that trivial. And I don't know how many of you have tried to like share state, simple primitive state, like strings and arrays and maps, between your Terraform and your containers, or your Terraform and your Lambda functions, right? And I've seen people do this in so many horrible ways, right? Basically, passing them through environment variables, which is probably the least horrible way. I've seen them pass through SSM parameters stores. I've seen them pass through buckets. I've seen entire systems built just to be able to like pass configuration or state across these two spaces. And in Wing, you can just reference it. You can reference files and strings and arrays and maps and any type of primitive serializable information. You can just reference it naturally across those boundaries. You can also reference other in-flight pre-flight objects. And so you can also lift other pre-flight objects. And so basically what I can do is I can call b dot, and then I see a bunch of APIs. I see the usual suspects, right? Like the data plane API of the bucket. Interestingly enough, if I do b dot here, outside of in-flight, I see the pre-flight API of this object. And that's a pretty unique thing about Wing. Like in Wing, every object, every class has both a pre-flight API and an in-flight API. And Wing has the context to understand what you can how you can interact with those objects based on this scope that you're at. OK, so let's write a file. And as soon as I save this, you see I didn't have to compile. I didn't have to watch anything. Like it's just working as I want it to work. And now I can invoke my function. I can see my contents of my bucket. Cool. So now let's build something. I don't know if I have, how much time do I have? 5 minutes?
6 minutes.
Can I get 5 more? What do I need to do to get 5 more? There you go. OK, I want to build a URL shortener, which is like a pretty lame example, but I like it because it's like, it's kind of like leaning on the cloud. Like if I just put a container that takes in the request, then I need to start like scaling it. It kind of uses it has some properties that make it really nice as an example for a cloud system. And so let's start by kind of jotting that out, I guess. I'm going to create a cloud API, which is going to be the API endpoint. And every time I do a GET request, then, sorry, you see I'm going to do the slash CFG would go to Config Mgmt Camp. Slash Wing would go to Wing. Slash whatever, that's the idea. And so I'm going to basically retrieve the alias here from the request. And so redirecting alias to something. And I'm going to return 307, headers, location, and just put something here for a test, quick test. And so now I have like my little API. Let's call this data plane, right? Like that's basically where users are going to hit, no, not here, here. OK. And I can actually test this. I can go to my browser, and I get a redirect. Great. Obviously, it'll also redirect to Wing for anything, right? Because I don't. And I can also see that I have like these logs emitting. OK, cool. So I've tested this manually. And now, as a good developer, I want to test it programmatically. So as I said, Wing is shipped with like a built-in testing framework. And so I can basically start writing a test. So let's do this, right? HTTP GET. Now I need the API endpoint. And always think, what happens in the cloud? Like, how would that work in the cloud? Like, I would need to deploy an API gateway, and like the API gateway would have a deployment, and it would have an endpoint. And we could just do API URL, and you get the endpoint. And I'm going to ask this to redirect manual, so it doesn't really redirect. And I can check here, response status, right? I'm going to bring in the expect module. 307. And I'm going to extract the location from the headers. I'm going to do it right. Location, and then I'm going to expect. Sorry, Winglang IO location. And let's make this fail for a second. So you see, as soon as I save this, I have like a little test. And I can run it, and I can check that it's failing. Nice. And now I'm going to make it pass. Great. So I have a little test, so I know that this is not going to break, and I can run this test every time I change something. And so now let's think about how to implement this, this URL shortener. I'm going to use a bucket, and so the key is going to be the alias, and the target is going to be the contents of the object inside the key. So let's create a bucket, call it mapping. And I'm going to basically say mapping.get alias is going to be the target. And so now basically this is expected to fail, I guess, right? Because I don't have because the target is not the target is not there. Let's see that it's, yeah. It didn't return what I wanted. It returned 500, right? Because the bucket didn't return anything. I can obviously like add some nice errors. I'm not going to do it right now. And so now what we want to do is we basically want to put, just to test this, I want to put, let's do wing. And so now my test is, sorry, my test is populating the bucket, and the request, it's just too fast, I feel sometimes. It's like, this is really doing anything. Like in the cloud, this would have taken me like 20 minutes for an iteration, like 10 minutes for an iteration. Go to the AWS console and dig up the logs and figure out what's going on there. And it's like, just that's how I want to build stuff. Okay, now let's create some control plane, right? Like I need to be able to actually create those shortened URLs. And so I'm going to create a class now, and I'm going to store the mapping object here. I'm just going to take all of this stuff, put it here, and I'll tell you why I wanted to do this. Okay, so now I have a shortener. You see that this is not compiling, obviously. I need the URL, so make it public. You see that I don't have to teach you Wing, right? Like I feel like I'm assuming everybody understands what I'm doing. Okay, so here I'm going to create a shortener, and here it's going to be SURL. And now I need to be able to actually create a shortcut, right? Like to create a short URL. So I'm going to define an in-flight method here that will allow me to create a short URL. And so this is going to require the alias and the target, and it needs to be public. And here I'm basically going to do the put operation, right? So basically now I've added an in-flight API to my URL shortener. And so now I can basically call create here. And let's check that it's all working. Now you see that what happened is that now my system has this new thing, right? Like it has like a shortener object, and I can, I can do whatever. I can create as many of them as I want, because now they're objects, and so I can create 2 shorteners, because that's a very useful thing. And so on and so forth. I actually had some other things that I wanted to evolve this example. Oh, no, there's one little thing that I wanted to add to this example is basically, let's say we want to collect some statistics, right? And so every time there's a hit, I want to count something and return the list of, how many times this was hit. And I thought about it, and I was like, I guess like this is control plane stuff. It doesn't need to be highly scalable. I don't even care if it's like deleted. It's basically something that I need for the control plane. And my way to do this is basically to create like a single container, right? Like just a single instance of a container. Every time there's a hit, I'm just going to go to the container and tell it there's a hit, and it'll count something in memory, and it'll give me a result. And so I've done that here. I call it a hit counter. And I've used a library called containers, which basically allows me to build containers with Wing. And you see that it points to a hit counter image. And so this is like a simple, very, very simple Node.js application that just counts in memory. And it has the hit counter has an API that says hit, and it'll basically send a post request into the container. And there's an API called query, which would basically send a get request to the container and returns the results. And so now I can basically bring this library, right? Hit counter And I'm going to instantiate that here. Sorry, I'm going to do it here. And when a get is happening, I'm just going to go and say this hit counter dot hit with the alias. And I'm going to add another public API that says stats that will return a map of numbers, which is basically for each. And it'll go and it says hit count query. Now this is compiling. I didn't need the 2 instances. That's definitely not going to help my. And it's actually building the container. So it's like doing a build of the container 1 more minute. It's just so nice to see this working.
Want to make you feel like your boss is waiting for the commit, you know?
Yeah, right. I'm just going to print the stats, okay? That's going to be. I'm not going to build an entire API just for the stats, which is something that I wanted to do, obviously. So I'm going to run this now, run this test, and you see the wing is 1. And if I hit wing again, let's just do this. So now my test is hitting wing 3 times. And now we see the wing is 3. And this is just one little container because that's what I wanted, right, in this case. OK, let me go back to this and just wrap it up. Where is this? OK, this is from Adam's talk yesterday. Definitely sharp edges still. Maturity is naturally an issue. We're still not in 1.0, but we're working on it. And you can see, like, I can already build stuff with it. We're actually building a Wing cloud with Wing, right? Like that's a big service that we're actually building with Wing all the way. Platform extensions are too low level. That's true. I haven't had time to show you platform extensions, but they're basically these backends that you can connect to the compiler, and we have some interesting ideas on how to make them higher level for DevOps engineers and platform team to be able to apply their concerns. There are some concerns around what we call accidental complexity, which is basically complexity that you don't intend. And so we think that we were able to create a cost model, and there are other sharp edges. You cut me off. OK. So thank you, everybody. It was great.